Packet page 2. Again, the first thing we needed to do is go through and recognize if we're talking about the opposite, the adjacent, or the hypotenuse. Again, because as we're going to discover, there's 3 ratios, and each of these ratios talks about a combination of 2 of those 3 sides. So as we continue to page 2, it says we need to find the value of each trig ratio. Express your answers as a fraction in lowest terms. So now we get into sine, cosine, and tangent. And again, hopefully you've noticed this. We haven't really introduced this yet. Sine, cosine, and tangent. Well, there's a interesting thing that we're going to learn here. It's called SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. I would strongly encourage you to write this down. Hopefully you guys have this in your note page. And actually, let me pause and look at that note page. It's been a while since I've made it. Yeah, put that in there. That's SOHCAHTOA. Side opposite hypotenuse, cosine adjacent hypotenuse, and tangent opposite adjacent. And we have the triangle sides, the opposite leg, the adjacent leg, and the hypotenuse. So make sure you understand all of these things, right? Because now we're going to talk about sine, cosine, and tangent, and how those work. And again, we have these 3 different ratios. So hopefully some of you guys already see where this is going. If we have a ratio where it's the opposite over the hypotenuse, and that's what we divide those 2 fractions together, we're going to use the sine ratio. If we have the opposite over adjacent, we're going to use the tangent ratio. So it just sort of matters what combination of sides that we have, and then we're going to go from there. So it wants to know, what is the sine of C? Well, angle C is right here, and sine is opposite over hypotenuse. So its opposite is 21. Right? So the sine is the opposite over the hypotenuse. So the sine is 21. I'm sorry, the opposite is 21, and the hypotenuse is 29. That is going to be the sine of C. If we jump down and we do the cosine of C, you'll notice cosine is adjacent over hypotenuse. So I'll start right here. Again, this is my opposite side. This is my hypotenuse side. And the side next to it's my adjacent side. So if I want the cosine, I want the adjacent over the hypotenuse. And what I'm going to do is I'm going to say, all right, my adjacent is 36 and my hypotenuse is 39. By the way, I don't expect you to know this yet, but I do want to give you a little bit of a payoff of where we're going here. So if I just divide 36 by 39, what's going to happen is I'm going to get a ratio, 0.9231. So 0.9231, and I'm looking at cosine. So what I'll do is I'll go over here and I'll go cosine 0.9231. You can see it's somewhere between 22 and 23 degrees, right? Looks like it's a little bit closer to 23 degrees. Well, that means that this angle must be about 23 degrees. Now, I'm not expecting you to get the angles yet. I just want you to see where we're going. And again, this is all we're doing for now, but I want you to see how we can use this to get that ratio, and then with that ratio, we look at our trig chart. Again, just trying to give you a payoff of where we're headed. Now, the tangent is opposite over adjacent. So the tangent is going to be the opposite over the adjacent. And I want the tangent of A. Well, here's A. Again, this is my opposite side. This is my hypotenuse side, and this is my adjacent side. Well, in this one, I don't care about the hypotenuse. This doesn't matter to me. All I care is that the opposite is 12, and that my adjacent is 35. And again, what I would do is I would divide those, get a ratio. When I got that ratio, I would go back over to the tangent and figure out which angle matched up with that. So that is trig in a nutshell. But again, we're just going a little bit at a time. So we have an example, again, of looking at a sine where we have opposite over hypotenuse. And again, we didn't care about the adjacent. That was irrelevant. We have an example where we did cosine, which was adjacent over hypotenuse. And we didn't care about the opposite because cosine doesn't care about the opposite. And we had an example where we did the tangent, where we had opposite over adjacent. And again, we didn't care about the hypotenuse because Tangent only cares about the opposite and adjacent.